or different elements have different atomic radii. So atomic radius of various elements depends on the number of protons. But the number of protons also influences the number of energy levels. But if elements are in the same periods, we count the number of protons. But if elements are in different periods, we just count the number of energy levels, because different elements have different number of energy levels. That means that they fall in different periods. For example, when you are asked to compare the atomic radii of sodium and potassium, sodium has atomic number 11, while potassium has atomic number 19. So when we write electron configuration of sodium, it is 281. But when we write electron configuration of potassium, it is 2881. So when we compare this number of energy levels, we find out that potassium has 4 energy levels, while sodium has 3. So we can conclude from this number of energy levels that potassium has a larger atomic radius than sodium. And the reason being, potassium has more energy levels than sodium. So in conclusion, when elements are in the same period, to compare their atomic radii, we count the number of energy levels. So the one with more energy levels is larger than the one with fewer energy levels. But the one with the fewer energy levels is always smaller. So that is how we compare atomic radii of different elements that are in different periods. But if elements are in the same period, when maybe we want to compare elements of in the same periods, that one means that these elements have same number of energy level. For example, I just want to write just an example here. Let's compare atomic radii of aluminium, which is number 13, and magnesium, which is number 12. Right? So aluminium is number 13. Let's write this electron configuration. Aluminium has an electron configuration of 2 to 8 to 3, while magnesium has an electron configuration of 2 to 8 to 2. So when two elements are in the same period like this, aluminium is period 3. Magnesium is also in period 3. So in this case, we count the number of protons. So we don't, because they are having same number of energy levels, so we count the number of protons. Aluminium has 13 protons, while magnesium has 12 protons. So the element with more protons is the smaller one. So in this case, aluminium is the smaller one, while magnesium is the larger one. So the fewer the number of protons, the larger the atom. The more the number of protons, the smaller the atom. So in this case, we can explain by saying that increase in the number of protons in the nucleus of an atom increases nuclear charge. So this one increases the effective nuclear force of attraction on energy level. So that atom tends to shrink more and become small. While when the atoms are fewer, the nuclear force of attraction is weaker as compared to the other one. So the atom remains larger. So when the atoms are in the same period, we just count the number of protons. So the one with more protons is smaller. Reason, because increase in the nuclear force of attraction increases effective nuclear force of attraction on energy levels, so the atom tends to shrink and become smaller. But when the protons are fewer, nuclear force of attraction is a bit weaker. So the atom remains larger as it sags, and it remains larger. So the smaller the number, that one means that the atoms are few, the protons are few. But the larger the number, the atoms are few. But when the number is small, the protons are few. Therefore, the atomic radius remains larger. And that's all for today.